Alright, in this video we're going to be talking about writing and interpreting an equation of a linear function. So write the equation of a line for the given graph below. So steps, we want to identify 2 points on the graph, such as 4, 0 and 0, 7. We want to calculate the slope, so let's start with that. So our slope, so here we'd have 4 minus 7 all over 4 minus 0. So 4 minus 7 gives us negative 3. 4 minus 0 is 4. So we have a slope of negative 3/4. We want to identify the b value in this equation y equals mx plus b. And this one is pretty nice because that b value, remember, that's when we intercept that y-axis. And so we see that the b value in this case will be b is equal to 7. So now we're going to rewrite the equation into this form. So we would have y equals negative 3/4 x plus 7. And that's our equation. All right, modeling with linear functions. So writing an equation for a linear cost function. So suppose Shamika starts a company in which she incurs a fixed cost of $1,250 per month for the overhead. And overhead is basically the cost to rent the building, everything like that, all the costs associated to that, which includes her office rent. There you go. Her production cost is $37.50 per item. Write a linear function C where C of x is the cost of x times items produced in a given month. So we're going to start off with C of x. Let's make sure we identify our variable x. What does x represent? X is the items produced in a given month. And we should be specific here. We really should say the number of items because x is going to be a number. So our cost function C of x is going to look like mx plus b. So we need to figure out what the m is and what the b is. So remember, b, when we talk about b, that's also our initial value. So no matter what happens, how much items we produce, we have to pay the $12,050 because that is our initial value. That's our fixed cost up front. Right, and so that ends up being our b value. Again, because that's the initial value. And so now we know that we are spending $37.50 per item. So this is our rate of change. Also known as our slope. Okay, so now we can come over here and rewrite this. So this is going to be $37.50 plus $12.50, and that's our cost function, C of x. Right. Let's look at another example. F of x is a linear function with f of 2 equaling negative 11, f of 4 equaling negative 25. Write an equation for the function in slope-intercept form. Remember that slope-intercept form, that's just f of x equals mx plus b. So we need to be able to translate this out of function notation. So out of function notation, this is going to look like x is 2, y is negative 11. Out of function notation, this is going to translate to 4, 25, negative 25. All right, as always, we want to find that slope first. So our m is going to be the change in y over that change in x. So the change in y is going to be negative 25 minus negative 11 all over 4 minus 2. Alright, so negative 25 minus negative 11, that is in fact going to give us subtraction because of that double negative there. So we're going to end up with negative 14 all over 2 which gives us a negative 7. So now we still need to figure out what our b is, what that y-intercept is, and we don't know what it is because we don't know yet what x equals 0 for this equation. So we're going to pick one of these values. Let's go ahead and pick this one, and we're going to plug it in. So we have f of x equals mx plus b, but this m we already know is going to be negative 7. Okay, so what I'm going to do now is I'm going to plug in negative 11 and 2. So negative 7 times 2, that gives me negative 14. This equals negative 11 plus b. I'm going to add 14 to both sides. So negative 11 plus 14, that gives me 3. So b equals 3. That means now that my function, now that I know what b and m is, now I can go ahead and plug that in. So I get f of x is equal to negative 7x plus 3. That's our function. Let's talk about graphing linear equations. We've talked about this already a little bit, so this might be review, and that's okay. So we want to make sure that the equation is written in slope-intercept form. So this is going to be huge in order for us to graph it easily. If it's written in standard form like this, all right, we're going to want to move this around in order to get it into y equals form. Okay. All right, so we want to identify the slope and our y-intercept, because it's going to be important. We're going to plot the y-intercept first, followed by the second point following the slope. So again, we're going to start with the y-intercept, and then we're going to look at the slope. And just like before, we looked at the movement of the slope. So a positive slope is going to be up and to the right. A negative slope is or down and to the left. So remember, notice they're either both positive or they're both negatives, and they makes these movements. Negative slope, it's only one is negative, so it's either going to be down and to the right, or it's going to be up and to the left. So only one of them changes direction. All right, let's take this one as an example, and let's go ahead and plot this. So we're going to start over here again with this y-intercept. So I'm going to go to positive 1 and make a dot. Okay, there's my y-intercept being plotted, and now I'm going to use the slope. So now slope, remember slope is rise over run. So this I'm going to rise 1 over 2. So I'm going to go up 1 over 2, 1, 2. Okay, I can also go down 1 over 2, 1, 2. So this is our line that we form here. Okay. All right, let's try this next one. So we have the function f of x is equal to negative 3/4 x plus 6. So we're going to go ahead and come over here to 6. So we're going to go up 1, 2, 3, 4, 5, 6. Here's our point. Now my slope, though, remember, negative 3 over 4. This translates to rise over run. So I can go down 3, 1, 2, 3, over 4, 1, 2, 3, 4. I can also go up 3, 1, 2, 3, over 4, 1, 2, 3, 4. And here is my graph. Okay, and notice that it is negative, and that's what I wanted. If I wrote the word hope on it, it would be going downward. All right. And that finalizes the notes for the section.